Measurement of length and motion. So introduction. Measurement is crucial in our daily lives for various tasks like buying fabric, cooking, or building structures. Accurate measurements ensure that we can communicate quantities effectively and consistently. For instance, if you want to buy fabric to make a dress, you need to know how much fabric is required. Similarly, when following a recipe, precise measurement of ingredients is necessary to get the desired taste and texture. Without measurements, it would be challenging to build houses, manufacture products, or even perform simple tasks like buying groceries. Okay, so this measurement, yeah, we need the measurement in daily uses. Okay, then how will you measure the shirt? To make the shirt, we have to measure the first cloth. Okay, and taking the proper measurements, we have to buy the shirts and the pants. Now, how do you make the curry? How do you make the curry? So for making curry, you need some ingredients. Okay, and for how do you take the ingredients? Why are you laughing? Where do we use the measurements? Yes.
For making curry.
For making curry, we need ingredients, right?
For the
Right.
scale of making houses.
Okay, to make the houses and to make the buildings, we need measurements. Yes.
To measure the field.
To measure the field also, we require measurements. Any more else?
For making.
Okay, for stitching the dresses, measurement is required. Yes.
To make furniture.
To make furniture also, measurement is required. To make different types of inches, 75-inch TV, 65-inch TV, measurement is required. Yes, very good. Next, one more. Anyone? Okay. So for these things, we need some measurements. Now you see here. How do we measure? By using which instruments or by using which devices we can measure? By using what are the things are there to measure? Yes.
Scale.
Scales, measurement tapes,
Measuring
tapes,
iron rod.
iron rods, iron rod. Okay. Okay. How do we measure? Do you think the length of the bench would be same if you measure in different people's handspan? By using the handspans also we can measure like this. Okay, here we can using the handspan and by using our feet also we can measure the length of the room. Okay. By using the handspan also we can measure the length of your bench. Yes or no? How can using a scale or measuring tape help avoid mistakes in the measurements? Okay, this will give some mistakes. When you use your handspan or when you use your feet, this will give some mistakes. Okay, please don't touch. Now you see, measuring using the body parts. Then how do you measuring using the body parts? Body parts such as handspans, arm lengths, and foot lengths were commonly used for the measurements in the past. Previously, we didn't have any scales, measurement devices. Okay, previously they were used to measure only their body parts only, like handspans, and they used to measure some feet. Handspan. How they use the handspan? The distance from the tip of the thumb to the tip of the little finger when the hand is fully stretched. All of you, please stretch your hands fully like this. Everyone, please stretch your hands fully like this. Okay. Then how to measure? How to measure this? You take this length. Yes, you take this length. From where to where you have to consider this length? From tip of the thumb, from here to and to the little finger up to here. We need some. You have to calculate like this from tip of the thumb to from little finger. So when the hand is fully stretched, then only you can consider this. Okay. So all of you, please stretch your hands fully. You measure your bench length.
11.
How many inches are there? It is. How many inches are there? Your table is how many inches are there?
11.
How many handspans are there? How many handspans are there?
3.5.
Three and a half. Yeah, exactly. That is the table is 3.5 measurements. Okay. Now, how do we measure the length by using your arm?
The distance from shoulder to the tip of middle finger.
Okay, we can measure the length by using your arm from the distance from the shoulder. Means you have to consider your shoulder is here, right? So you stretch this fully hand. So he folded this hand. Eventually, so you have to do now. So from the shoulder to this middle finger. So straightly you have to stretch your hand. Not you don't fold this hand like this. Stretch your hand fully. And you have to consider from the shoulder to tip of this point. Okay. Then stride. Next one is stride. Farmers sometimes use their steps or strides to measure the lengths for the dividing their fields. Strides means feet. We can measure the fields in the length by using our feet. Okay. So farmers sometimes use their steps. These steps also be called as strides. By using their steps, they can measure the length of their fields. Okay. How farmers measure their fields? How farmers measure their fields?
By the usage of steps or
Okay.
stripes.
Okay. By using their steps or strides. Now, can we take these measurements as standard units?
No, sir.
Why we cannot take?
Because different people have different sizes of their body parts.
Very good. Because different people have different sizes. But your hand span is size is different with your friend hand span. By using your hand span, what is the table measurement you are telling now?
3.5.
3.5.
Yes.
Someone is telling 4.5. Means one of your hand is one of your friend hand is more than of you. Means the different hand spans are having different sizes. It cannot give the different measurements. Can we take these are the standard units? No. So what are the issues with non-standard units? Here we have, now you see. Issues with the non-standard units are using body parts for the measurement has a significant drawback. It is not uniform. Since people's body part vary in size, the same length can be measured differently by different individuals. Here we have your, you see here. Now you see, different peoples are having different size of the hand span. So they, if they measure with a different hand, what happens? What happens?
You will get the
You will get the different values. So this variation can lead to inaccuracies and confusion between the people. For example, if you and your friend both measure a table, let us assume you and your friend measure a table by using your foot, right? You might get different results because your feet are not same size. So this inconsistency highlighted the need for the standard units of the measurement. Okay. So now in ancient time we actually we used to measure the length by using your body parts like hand span, arm, and one more length is what? What is that? One more is foot. By using your feet or stride, that is also be called as strides. Previously farmers are used to uh, use their feet to measure the length of the field. Now in ancient time, Indian measurement system. Let us see now. Ancient Indian measurement system. Here we have three types of ancient measurement systems. What are those? Those are and units like angula, so which is measured by using finger, and dhanusha and yojana. These were used in the ancient Indian literature for the measuring the things like artigraphs, building, and town layouts. Town layouts. Okay. The angula is still used by today by traditional workers. Who are using this angula system? By carpenters and tailors. Then archaeologists have even found objects with marking, possibly scales, at Harappan civilization sites, showing the use of these ancient measurements. Okay, and how many types of Indian ancient measurements are there?
There are 3 types.
There are three types. What are those?
The first one is Angula, and the second one is Dhanusha, and the third one is Yodhana.
Yes, first one is Angula, second one Dhanusha, and third one is Yojana. This Angula system is used by whom?
This Angula's measurement is used by traditional workers such as carpenters and tailors.
Yes, this Angula is still used today by traditional workers such as carpenters and tailors. And this Dhanusha and Yojana were used in the ancient Indian literature for measuring the things like the artifacts, articrafts, buildings, and town layouts. Okay, where we can use this Dhanusha and Yojana system? Where we can use this Dhanusha and Yojana system?
Artifacts, building,
Measuring things like.
artifacts, building, and town layouts.
Very good. To measure the artifacts, building, and town layouts, they used here which systems? Dhanusha and Yojana. Is it clear, everyone?
Yes,
Is it clear?
Yes, sir.
Is it clear, everyone?
Yes, sir.
Is it clear?
Yes, sir.
So we have one MCQ questions, right? You have to tell the answer. Which of the following is a drawback of using body parts for measurement? Option A is inconsistent measurement due to variation in body sizes. Option B, increased accuracy in measurements. Option C, standardization of units. Option D, ease of communication. Can you tell the answer? Yes. What is the answer?
A.
Option A. Very good. This is an inconsistency in measurement due to variation in body sizes. Here we have some explanation also. Now you see this explanation. Using the body parts for measurements can lead to inconsistency. Different individuals have varying body sizes leading to inaccurate measurements. This lack of uniformity highlights the need for standardization units of measurement. Is it clear everyone? Okay.
Yes, sir.
Standard units. Okay, here we have standard units. Over time, different parts of the world developed their own system of measurement. However, as people began to travel more, these varied systems caused confusion. Matlab, now, every country has its own measurements. When these people travel to another country, for this measurement they will get confusion. For example, we are measuring the distance in kilometers in Indians. Indians are measured distance in kilometers, but US people they measure distance in miles. So this will lead to confusion. So to remove this confusion, here we have solution. What is that? All countries came together and agreed on standard set of units known as that is International System of Units or SI unit. Okay, International System of Units are also be called as what? SI units. SI units will give the larger units, right? What is the SI unit of the length?
Meter.
Very good. SI unit of length is meter, and the symbol to measure this meter is M. Okay. What is the symbol to measure the meter? M. M indicates
Meter.
meter. Then 1 meter is divided into how many equal parts? Again.
100 equal parts.
Then each equal part we call as centimeter.
Centimeter.
That indicates 1 meter is equal to how many centimeters? 100 centimeters. 1 meter is equal to 100 centimeter. So in this 1 meter we divided into how many equal parts? 100 equal parts. In this one equal part we called as 1 centimeter. Then how do you indicate the centimeter in short form? That is cm. Cm indicates 6 centimeter. Do you have your scales? Yes. All of you see your scales. This is in centimeters are there, in meters are there, or inches are there? Can you tell? One side it is in centimeter. Other side you see inches are there. And your scale is marked up to how many units of centimeters? 15 centimeters. Okay. Here also we have scale. Scale starts from the 0 and it ends with the 15. This is the smaller scale. Is it clear everyone?
Yes,
Yes,
sir.
sir.
Okay. Very good. Nice. Okay. Now you tell what is the SI unit of length?
Meter.
SI unit of length is meter. And 1 meter, if you divide it into 100 equal parts, then one equal part we call as what?
Centimeter.
Centimeter. What is the short form to indicate the centimeter?
cm.
What is the short form to indicate the meter?
M.
Small letter. Okay. Please look at here. Each centimeter is further divided into how many parts? 10 equal parts. Okay. Each centimeter further divided into how many equal parts?
10
equal
equal
parts. Then again the one equal part we called as millimeter.
Millimeters.
One equal part we called as millimeter.
Millimeters.
Now you see this 1 centimeter. Listen, I need one more color. Okay. So 1 centimeter we divided into how many parts? 10 equal parts. 10 equal parts. Then each equal part we called as
1 millimeter.
10 equal parts. Then this 1 millimeter we called as 1 by 10th centimeter. Can I say like this? Okay, 1 centimeter को कितना parts किया हम? 1 centimeter is divided into how many parts? 10 equal parts. Then each equal part we called as 1 millimeter. 1 millimeter is nothing but it is the 1/10 of the centimeter. Can I say like this?
Yes, sir.
1 meter is nothing but it is the 1 by 100th part of the meter. Can I say, 1 by 1 centimeter. So 1 centimeter is nothing but it is a 1 by 100th part of the meter. Can I say like this?
Yes,
Is
sir.
it the confusion, sir? So 1 meter equal to how many centimeters?
100.
100 centimeters. 1 millimeter, mm, we indicated millimeter with mm. 1 millimeter equal to how many centimeters? 10 centimeters. Remember this. Okay. Sorry, 1 millimeter, 1 centimeter. Sorry. So 1 millimeter equal to 0.1 centimeter, or 1 centimeter equal to how many millimeters? 1 centimeter equal to how many millimeters? 10 millimeters. Now you see 0 to 1 centimeter, how many lines are there? You see there in your scale. All of you please observe your scale. 0 to 1, how many lines are there? How many lines in between we have? How many lines? 10 lines are there. Okay. Then one line we called as 1 millimeter. That means the 1 centimeter equal to how many millimeters? 10 millimeters. 1 meter equal to how many centimeters? 100 centimeters. Remember all these things. Okay. Okay. To avoid the confusion in measurements, what did all countries? What did all countries? Yes, children. You have
We
to tell.
made international system of units.
And also we called as SI.
SI units.
What is the SI unit of length?
Meters.
Meter. And this we indicated with the letter.
M.
And 1 meter equal to how many centimeters?
100 centimeters.
Very good. And 1 centimeter equal to how many millimeters?
10 millimeters.
Then how do you indicate millimeter?
Mm.
Mm. Nice, super. Measuring large and smaller lengths. Everyone please look at here. To measure the large distance, we use a unit called kilometer. 1 kilometer equal to how many meters? 1000 meters. Then how do you indicate the kilometer? In which letter?
Km.
Capital K, small m. Okay, km. And 1 kilometer equal to how many meters?
1000 meters.
1000 meter. For smaller lengths, we use these centimeters and
Millimeters.
All of you please measure your pencil length by using your scale and tell that length. All of you please measure your pencil length by using your scale in centimeter. Yes. Can you tell the now measurement of your scale?
Centimeters.
How much?
14 centimeters.
Very good. That is 14 centimeters.
16 centimeters.
16 centimeters. That means 15 centimeters. One of your friend is telling 15 centimeter. So that means what is 15 centimeter tells you? That is 15 times the length of 1 centimeter. Okay? 15 centimeter indicates that is 15 times of length of 1 centimeter. 1 centimeter into 15, 15 centimeter. Yes or no? Suppose, what is the distance between your city and Hyderabad city? That is around 300 kilometers. Yes or no? 300 kilometers. 300 kilometers. 300 kilometer equal to how many meters can you convert? Yes. 1 kilometer equal to how many meters? The distance between your city and your village to your nearest city Hyderabad is how many kilometers? 300 kilometers. 300 kilometers means how many meters? 1 kilometer is equal to how many meters? 1000 meters, right? 300 into, in the place of kilometer you put 1000 meter. 1000 meter. Okay, this will be how much here? Here with 2 zeros, here with 3 zeros. How many meters?
3 lakh meters.
That is equal to 3 lakh meter. Is it clear, everyone? Okay. So what is the distance between what is the distance between two villages? Means here to Hyderabad is how much distance? 300 kilometers, which is equal to 3 lakh kilometers. How do you convert this kilometer into meter? By multiplying with 1000 meters. 3000 kilometer is equal to 3 lakh meters, not kilometers. Okay. Now here given the one example, if the distance between two cities is 20 kilometers, what it will indicate? 20 kilometers means 1 kilometer equal to how many meters?
1000.
1000 meters. So to convert into the meter, so you have to multiply with 1000. 20 into 1000 is how much?
20,000. 20,000.
20,000 meters. Is it clear, everyone? Okay. Now, okay. Then conversion between units. Now we already know that 1 meter, 1 centimeter, 1 kilometer, and different conversions also. Okay, now you have to tell 1 meter equal to how many centimeters?
100 centimeters.
Very good. 1 centimeter equal to how many millimeters?
10 millimeters.
1 kilometer equal to how many meters?
1000 meters.
Okay, now you tell 1 kilometer equal to how many centimeters?
1 lakh centimeters.
Very good, very good. 1 lakh centimeters. How it is? Now you see. I will give the answer. Now you see, 1 kilometer equal to how many meters? 1000 meters. Yes or no? Then how will you convert it to centimeter? So in the place of m, you put 100 centimeters. 1000 into 100. So it will be how much? Here we have 3 zeros, here we have 2 zeros. Total 5 zeros are coming. So this is equal to 1 lakh centimeters. Okay. Is it clear? 1 kilometer equal to 1000 meters. 1 kilometer equal to 1 lakh centimeters. Correct way of measuring length. Different scales are used for different lengths, for example. So to measure the length of pencil, we can use scale. Okay. To measure the length of the room, we can use measuring tape. Very good. To measure the circumference of the trees,
Measuring tape.
or to measure the chest, your body chest,
Measuring tape.
measuring tape that is flexible, which is used by the tailors. Yes or no?
Yes.
The measuring tapes are used by whom? Tailors. Okay. So now you see here we have. What is the correct way to place the scale? Then how do you put the scale to measure the length of your paper? How do you, so all of you please measure your textbook length now in horizontal direction, in vertical direction, and tell your length. Tell your textbook length. Do it. Then how do you place the scale? Always remember you have to place parallel direction to your paper. Okay, put the scale like this, not in cross way. The scale should be placed in the contact with the object along its length. If you are measuring the length of a paper, place the scale so that it touches the paper along its entire length. Can you tell now what is the horizontal length of your textbook? Horizontal length and vertical length. Yes. Scale को कैसा use करेंगे? Don't put scale crossly. So already it is there. This is the correct way to measure the length by using the scale. This is the correct way. Now you put the scale like this. Don't put in cross direction. So you put parallel direction to your paper. Okay, this is the correct way to measure to keep the scale on your paper. So don't put like this cross. Don't put your scale cross like this. Okay, put straight like this on your paper. Now can you tell what is your length of your textbook, curiosity science textbook length in vertical direction, in horizontal direction? Approximately you can tell, no problem. Approximately. Yes, measure the length of your textbook. Can you tell the answer now? What is this length? Yes, what is your length of your textbook in this direction and this direction?
60.
How much it is?
20 centimeters.
Yes, approximately it is 20 centimeter. The curiosity science textbook length is 20 centimeter. Now in this direction?
20 centimeters.
Very good. 26 centimeters. Okay. So all of you please measure and check the is it correct or not. Everyone please measure. Then what is the correct position of the eye while reading the scale? While seeing the measurement. So from where you have to see the reading? So you have to see your eye should be placed directly above the point of measurement to avoid the parallax error. So which can lead to incorrect readings. So for example, if you are measuring the length of your pencil, your eye should be directly above the point where the pencil meter meets the scale. Okay. Now you see here we have one example where you have to place the eye. Here we have the different position given in this figure. So you have to place here in between A and C. So you don't put eye. This is eye. This is eye. Okay, this is eyeball, and this is the C. So which one is correct position to place your eyeball? Eye. B position. Okay, you have to see from here. Don't see from this side. Okay, you have to see from this side and you have to see it from this side. So you have to keep your eye directly on the nib of pencil like this. Okay, is it clear everyone? Yes or no?
Yes, sir.
Okay, so don't keep A in direction of A and C. So you have to keep your eye directly on B position. Okay, from here you have to see. Now, how to measure the length if the ends of the scales are broken? How to measure the length if the ends of the scales are broken? Ends of the scale को तोड़ दो.
नहीं सर मम्मी मारेगी.
अरे यार तोड़ दो मेरे लिए. Now, if the ends of the scales are broken, you can still use it for the measurement. Everyone, please keep quiet. Use any other full mark on the scale as the starting point. The reading at the end of the object is then subtracted from this mark. Find the length. Now you see here we have one example. Suppose इधर हमारा end of the scale इधर क्या हो गया? टूट गया. Means it is broken here, right? So you measure, even though you can measure. See here. You put the scale here on 1 centimeter. Okay, 1 centimeter, and you measure from here up to here. Let us say this is approximately 10. Let us say this is approximately 10. Can you guess the length of this paper, yellow sheet paper?
9
Yes.
centimeter. 9 centimeter.
You have to subtract 1 centimeter from total 10 centimeter. Why? Because we started from the 1. We didn't start from the 0. Zero से we 0 से start नहीं किया, हम 1 से start किया. Okay, so इसलिए आप 1 subtract कीजिए. तो 10 centimeter 1 minus 1 centimeter equal to how much? 9 centimeter. This is the correct method of placing the scale with broken ends. Is it clear, children?
Yes sir.
Okay. Now, writing units of length correctly. When writing units of length like kilometers, meters, centimeters, and millimeters, the names and their symbols km, m, cm, mm always start with lowercase letters, except at the beginning of a sentence. The symbol should never have an s added to the plural, and no full stop is placed after the symbol unless it's at the end of the sentence. Also remember to leave a space between the number and the unit when writing the length. Now you see, how do you write the units? Now you see 10 centimeter. You should not write like this, 10 centimeters. Don't keep s here. Okay? While writing the units, don't keep s here. And leave some place between number and its units. For example, 10 centimeters you have to, and don't put full stop also. Okay, so you write like this 10, and also you give one space and you write cm here like this. Okay, don't put s symbol, and don't write s, and don't keep full stop, and don't write together like this. Okay, while writing the units, always remember, after writing the number, give one space, leave one space, and write its units, and don't put any full stop, and don't write yes also. To make it plural, don't put s. 10 centimeters. We can read like this, 10 centimeter, not 10 centimeter. We can read 10 centimeters, but no need to keep this, no need to write this s, and no need to keep this full stop. Okay, always remember while writing the, suppose 100 kilometers are there, you should not write like this 100 kms, kilometers. Don't write, and don't keep full stop. And how to write? First you write the 100, you give one space, and you write km. That's all. This indicates 100 kilometers, and don't put the full stop also. Full stop also. Is it clear, everyone?
Yes.
Okay.
Yes,
And now measuring the length of curved line. Okay, how do you measure the length of a curved line? Can you measure by using this scale? Can I measure this using this scale? By this? Can you measure this curved line by using the scale?
no.
So for this you have to take one thread. Okay, so you place the thread on this curved line. Okay, now you take the thread and keep this thread on the scale. Okay, now what you have to do, take this thread outside and keep this thread on your scale. So in this way we can measure the length of the curved line. Suppose you make one circle like this. Okay, you take one thread, you put the thread here. Okay, place the thread on this line, on this circle, and end of the thread you end it here, and you take the whole length and keep it on your scale, and measure the length. So that will give the circumference of the circle. To measure the curved line, so we have to use thread. So you place the thread on this curved line, and the same thread you bring it on the scale. Now we can measure the length of the curved line. Now you see, curved lines can be measured using flexible measuring tape. What is that flexible measuring tape? Or a thread. By using thread also we can measure. Wrap the thread along the curve, then straighten the thread and measure its length using a meter scale. Okay. Now here we have one question is there. What is that? Which unit of length is equal to 1000 meters? Centimeter, kilometer, millimeter and inch. Which one is the right answer? Kilometer. Very good. The answer is B. Okay. Now here we have centimeter, kilometer, millimeter and inch. Already you know about centimeter, kilometer, millimeter also. But what about inch? What about inch? Inch means 1 inch is equal to 1 inch is equal to how many centimeters?
2.54 centimeter.
After point you don't read 54, you have to read 54. Okay? After point, how to read the numbers? 2 1 inch is equal to
2.54 centimeter.
yeah, don't read 54. Okay? 2.54 you read space centimeter. Okay? 1 inch equal to how many centimeters? 2.54 centimeters. On your scale, on back side of your scale, it is there in inch. Okay, you see there. Now, come to here. So, describing a position, you have to need reference point. Reference point means with respect to one reference points where you are. For example, how much distance is there from your school to for your home? From your home, how much distance is there in between school to your home? So how you are measuring? Reference point is school, but ending point is your home. And also, this reference points is required to measure your position from that particular point. Reference point means you have to measure your length from that point. For example, here we have the starting line in a race and the kilometer stones on a highway. Have you seen these kilometer stones on highway?
Yes, sir.
It will give the distance you traveled. The landmark such as buildings also. The landmark such as building or tree or we can take as a reference point. Importance of consistency of reference point. Using consistent reference points ensures that measurements and descriptions of positions are accurate and comparable. If everyone uses the same reference point, when describing the location of a place, it eliminates confusion and ensures clarity. Everyone should take the same reference point to measure the length. Okay, so you don't get confusion by taking the different references points. For example, Ashwapuram to Hyderabad. What is the distance? From where you have to take the reference point? The center of the township or the center of the village. It will start from the zero. From where to you have to measure the Hyderabad? हैदराबाद बॉर्डर में नहीं रखने का रेफरेंस पॉइंट कहाँ रखने का सेंटर ऑफ द सिटी मिडिल ऑफ द सिटी मिडिल ऑफ योर विलेज टू middle of your city. The distance between Ashwapuram to Hyderabad from where to where you have to take middle of the village to middle of the Hyderabad city. That is the reference point. You have to consider that reference point only to measure the distance between the two villages or two cities. Now you see importance. Now we have here moving things. Then what is moving? What are the moving things? How do you know that the things are moving? How do you know that the things are moving? If they are moving, how do you know that if they are moving or not? With respect to time or with respect to observer. Now you see all are observing me, right? Is there any changing in my position? Is there with respect to you? My position is still here only. Suppose I am moving like this, but you are watching my position. My position is changing with respect to time. Then we can say that the object is moving. Okay. Here, how do you confirm that objects are is it rest or motion? If object is considered to be in motion, if the position changes over time related to a fixed reference point. Suppose, listen, two persons are there. They are traveling in same train. Then one person is saying you are not moving. but other person is saying we are moving. Who are correct? Trains, दोनों persons trains में travel कर रहे हैं. Okay, these two persons are traveling in the same train, and one person is saying we are not moving, we are at rest, we sat here. Okay, other person is telling we are moving. Then who are correct? We are at rest. Yes, we are at rest. जो ट्रेन में दो जगह में बैठ रहे हैं ना, उन दोनों के लिए एक को एक कैसा दिखाई दे रहा है? They are in rest. The persons are not moving. Train is moving, but persons are sitting there. But one person to other person, they are looking like us in rest. That means with reference to the person who is watching outside from the train, from him, for him, these two persons are moving in the train. So one observer is there. One observer is observing these two persons from the outside of the train. For him, the two persons are moving. Okay, and these two persons one to each other is at rest. अर्थमవుతుందా? Is it clear everyone? समझ में आ रहा है ना? दो पर्सन ट्रेन में रह रहे हैं ना, वो दोनों रेस्ट में दिखाई दे रहे हैं, एक को एक. ये दो पर्सन्स को बाहर से ऑब्जर्व कर रहे हैं ना, वो एक और एक पर्सन, उनको कैसा दिखाई दे रहा है? ये दो पर्सन्स ट्रेन के साथ मूव होना लग रहा है उनको. ठीक है. नाउ how do you measure the motion and rest with respect to observer or reference? That observer we called as reference point. Okay. An object is considered to be its motion if position changes over time relative to the fixed reference points. If the object position does not change with respect to the reference points over time, it is said to be rest. Means simply you have to understand like this: if position is not moving with the time, then person is said to be at rest. If position is moving with respect to time, with respect to the observer, then we can say that the person is motion or the person is in moving. Is it clear? Now you see. And here we have one figure. Let us see this person. From this reference point, we are measuring the distance. And this point we called as reference point. He is observing the motion of these buses. And whenever he is observing that, the bus initial position is here. After some time, the bus moved up to here. Okay, final position of the bus, and this is the initial position of the bus. Is both positions are same or moving? Moving. Student, initially the bus was at. Now you tell, what is the reference point of this bus? The bus is here. This is the initial position of the bus. After some time, the bus came to here. The position of bus changes from, let us say this is the position A to position B. Who is observing the position of the bus? This person is observing. To him, the bus is moving. The bus position is changing from point A to point B. This indicates the bus is in motion. Okay, is it clear everyone? Types of motion. We have three types of motion: linear motion, periodical motion, and circular motion. How many types of motions are there? Linear motion, periodic motion, and circular motion. Linear motion occurs when an object moves along a straight line. The direction of motion does not change, and the object continues along the same straight line. The speed and direction might change, but the path remains straight line. Examples: a car driving on a straight line, an athlete running in 100-meter dash. Now, okay, then linear motion means, suppose this is the line. Okay, the bus is, let us say this is bus, and it is moving along this path straight line, and this bus is, the motion of this bus we call as linear motion. Okay, examples for linear motions are a car driving on a straight road, an athlete running in 100-meter dash. Okay, and next one is, next one, and all these given figures are examples of linear motion. The mango falling from the tree, it is also moving in the straight line, and this one person is pushing one object, and in linear direction he is going, in straight line he is pushing, and all are doing parade in straight line. So all these examples for linear motion. Okay, next one is circular motion. Circular motion, already you know that. The motion of fan, motion of clock of the needle, motion of
Ferris wheel.
Ferris wheel. All these are examples of all these examples for circular motion. The motion of merry-go-round, the hands of a clock, a satellite orbiting the earth. These are examples for the circular motion. Circular motion occurs when an object moves along a circular path. In this type of motion, the object constantly changes direction as it keeps moving along the curve, always saying always staying the same distance from a central point. The path is not straight but curved in the shape of a circle. So example for the circular motion means the motion of merry-go-round, the hands of clock, and a satellite orbiting the earth. Okay, these are the examples for the circular motion. Okay, here one girl rotating one stone by tying with the one thread in circular path. The stone is moving in circular path, and these children are playing. Okay, they are moving in. These horses are moving in circular path. Okay, next one is oscillatory motion. Oscillatory motion means to and fro motion we called as oscillatory motion. Oscillatory motion occurs when an object moves to and fro about a fixed position. The motion repeats itself in regular intervals with the object moving it to one side then back to the other side and repeating this cycle over and over again, and this path of the motion is not linear or not circular also but swings between 2 points. Example for the circular motion is the motion of a swing, the vibration of guitar string, the momentum of pendulum. Okay, this type of motion we called as circular motion. The and sorry, oscillatory motion, not circular motion. Oscillatory motion are also we called as periodic motion. What is periodic motion? An object is said to be in periodic motion if it repeats its path after a fixed interval of time. Okay, and such type of motions we called as periodic motion. What is circular motion? In circular motion, object moves along the same circular path repeatedly, called as circular motion. Okay, and similarly in oscillator motion, an object moves back and forth in repeating pattern. So both circular and oscillator motions are example for the periodic motions. Oscillatory motions and circular motion, and they repeat their path again and again. If the path is repeating again and again, such type of motions we called as periodic motions. Here we have two types of periodic motion. One is oscillatory motion, other one is circular motion. The fan rotates in circular motion. The boy swing in a swing. The boy swings in periodic motion. Sorry, periodic motion, not periodic motion. Oscillatory motion. Okay, oscillatory motion means the to and fro, back and front motions we called as oscillatory motion. And oscillatory motion, circular motion. These are repeats their path. If they repeat their path again and again, such type of motions we called as periodic motion. Periodic motions again we classified into how many types? Two types. One is oscillatory motion and other one is circular motion. Oscillatory motion means to and fro motion, or front and back motion are examples for the what is that motion? Oscillatory motion. Circular motion means the object or any person rotates in same path. Again the path it is repeating called as circular motion. And this is your lesson. Thank you for watching. Please subscribe Samyans Academy.